this point, the back end of our application is fully featured. In later lectures, we will add some testing and make some performance adjustments, but as far as features go, we have everything that we need. The last bits that we want to add now, however, are about logging. So we're not going to be adding more services or user-facing background workers, but we will be adding the ability for an admin like us to see and use logs a little bit easier. In this lecture, we're going to go over logging to physical files on the file system. And in the next lecture, we're going to talk more about logging to the console in more advanced ways. So returning to the workers file, let's log out anytime a check is performed. And let's just log what happened, the outcome of the check, the new state of the URL, and whether or not an alert is warranted. Before we log it to a file, let's just log it to the console here so we can see what's coming. So we'll log check outcome, state, and alert warranted. I'm going to start up the app again. And remember, the checks will run immediately when the app starts, and then again a minute later. So we can see that these first two logs for the two existing checks have come through. There is no error. The response code that this one got was 302. The response code for this one was 301, and they were both up. They had both previously been up, and so no alert was needed in either case. Now I'm just going to kill that. And let's make the workers run a little bit quicker so that we can see logs coming in a little bit faster. I'm going to change this to run every 5 seconds instead of 60. And we'll see these two lines appear over and over again once every 5 seconds. Okay, now that that's ran a few times, we can kill that. What you just saw happen in the console is basically the same thing that we are going to want to do, but we want to send it to actual log files. And then later on, we're going to write a worker that will rotate the log files and compress them to make room on the file system and make it easier to manage the logs and look for logs at a past date. But for now, let's just focus on actually writing these kind of logs to a log file. So back up to where we console logged out, I actually want to add a couple more parameters to what needs to be logged. First, I want to say log the outcome of the check. I want to log the original check data, then the check outcome, the state, whether or not alert was warranted, and then the time of the check. Time of check should equal date now. And so I'm actually going to pull the time of check into a variable and then use that variable anywhere we had needed date now. So I'm going to move this stuff above here and use time of check as the variable for last checked. So we are still logging this to the console, and the next thing we'll do is change that. But for now, let's run it again, see all that data coming through. So you can see that it's a much larger blurb to go to the console, and this is one of the reasons that we want to send it to an actual log file, is this much data coming to the console is just very hard to grok for the user. So let's kill that. And now, rather than calling console.log, let's call workers.log. Workers.log doesn't exist yet, so now we can go about writing this function, which takes in all these parameters and then writes it to a file. So I'm going to go down here, just above where we put in the loop, and actually start writing this function. So we're going to say workers.log equals a function that takes in all these parameters. And since this is really just a private function, only used here, we don't need to do much sanity checking. So let's say that we want to form the log data, and then we'll go about actually writing it. So we're going to say that log data is an object, our logs are going to be written as JSON, so we're just going to form these big JavaScript objects. We're going to say that check equals original check data, outcome equals check outcome, state equals state, alert equals whether or not an alert was warranted, and time equals the time of check. Now that we have the log data object, let's convert it all to a string so that we can do something with it. And now let's figure out what to call the log file that we're writing to. So there's lots of different ways to write log files. You can write all your logs to the same file, or you can write different logs for different users or different logs for different checks. We're going to decide to write different logs for different checks, and then later on we'll go about splitting those logs up by timestamp. So there will be one log that is about this check from this time to this time, and another log that is about that same check from another time to another time. So for now, all we need to worry about is writing this log to a log file whose name is the same as the check ID. So we're going to say that the log file name is original check data.id. Now that we know which file we want to write to and we have the string that we want to write, all we need to do is append the log string to the file we want to write to. For that, we're going to call a function and a library that doesn't exist yet. So we're going to call logs.append, pass it the log file name, pass it the log string, and then it'll pass us back an error. We're going to say if there's no error, then we'll log out to the console that logging to file succeeded. And if there is an error, we're going to log out to the console that logging to file failed. Now, obviously, we're going to need to create this log library and the append function that lives inside of it. But before we do, let's go ahead and move up and require it where we know it's going to live. So we're going to say var logs equals require./logs. Now we can go about actually creating that file. So now logs.js lives inside of the lib folder, which is the same folder that this workers file lives in. So now let's go about actually writing this logs.append function in that new file that we just created. So I'm going to open it up and say that this is a library for storing and rotating logs. This is going to have a few dependencies that we'll go into in more detail later, but for now just know we need fs, which is the file system. We're going to need path, which we've used before, and we're going to need a library we haven't mentioned yet called zlib, which is all about compressing and decompressing files. That's zlib equals require zlib. We're going to want to store this library inside of a container. So we say container for the module. We're just going to call it lib. And down at the bottom, we are going to export it. Now, where are we going to write these logs? we're going to do something similar to what we did in data, where we, in the root directory, created a .data folder. But instead, it's going to be a .logs folder. So let's go ahead and create that. We're going to say make directory .logs. And now we have a place for all these logs to go. But just like we did for the data library here, we need to establish at the top of our file the base directory that we're going to be working in. And whereas for data, it was a .data folder, for logs, it's going to be logs. Now we can go ahead and start writing that append function. So this function will be append a string to a file, create the file if it does not exist. Remember, if we are dealing with check XYZ, we're going to be attempting to write that JSON string to a file called XYZ. If that file does not exist yet because it's the first time we've written it, or because later on we might have rotated that log out or compressed the old one, we want to go ahead and create the file before appending anything to it. So lib append is going to be a function that takes in a file name, the string that should be appended, and a callback. So we are going to do similar things to what we did in the data file. We are going to start by opening the file for appending. For that, we're going to use fs.open, call the base directory, add the file name, add .log, because we might as well call it .log since they are log files. We're going to use the A switch since we're opening it for appending, and we want it to be created if it does not exist. And they'll pass back an error and a file descriptor. If there's not an error and there is a file descriptor, we want to continue. Otherwise, we want to call back the error could not open file for appending. But if everything was fine, we want to append to the file and close it. So we will say fs.append file, which is a built-in function in that module. We want to pass it the file descriptor, and then the string, and then we're actually going to add on /n, which is a new line character, because we're going to be adding on JSON one line at a time, and we might as well add a new line character after each JSON string that we add, just to make it easier to parse, both visually and programmatically later on. That's going to pass us back an error. So we will say if there's not an error, then the appending worked fine, and we want to go ahead and close the file. But if appending the file hit an error, then we want to call back error appending to file. If everything was fine, as I mentioned, we'll call fs.close, pass it the file descriptor, they'll pass us back an error. If there is no error, we'll call back false, because we're using an error back. But if there was an error, we'll call back error closing file that was being appended. Okay, so that's the entire append function. So let's go ahead and try to run the app again, see if these new files get created in this directory, and if the data gets appended to it. So I'm going to start it up. We got logging to file succeeded, and no alert needed, which is the old logging that we used to do. Again, 5 seconds later, we got logging to file succeeded, and it seems to be working fine. So if we open up these files, we should see 3 in each of them, and we do. Each line has a different timestamp, and they are all on new lines, but besides that, they are pretty much all the same because none of this information was changing. All the checks said that the state was up, and there was no need to alert the user, so alert was always false. All right, so the logging is working fine, but as you can imagine, even though this is only going to be running once every minute instead of once every 5 minutes, these log files will get pretty big pretty quickly. And so once a day, we want to take the log files that have gotten full with data over the last day and use the zlib library to compress them, make them as small as possible. They should be able to make them very small because, as you can see, there are a lot of repetitive data. So we want to make them very small, then allow the app to add today's logs, today's JSON in a fresh empty file instead of appending to a larger and larger file. And after we compress the old logs, we want to save them with a timestamp in their name so that if we want to look up the logs from, let's say, January 1st, all we'd have to do is figure out what the file name would be for January 1st and decompress that file, then read the contents within it. All of that will make more sense as we go through this. For now, I'm just going to close these logs. And let's go back to the Workers tab, where we're going to add a new loop to the initialization script, telling the workers to go about compressing and modifying the logs, what we call rotating the logs, once every 24 hours. Right before we do that, I'm just going to change this back to run once a minute instead of once every 5 seconds. Let me clear out the terminal. Now let's add those workers. The moment the app starts up, we want to call one worker called rotate logs, and that is going to compress all the logs immediately so that an app that is just starting up will have all fresh logs for its services to write to. We're just going to call that workers.rotate logs. The other function that we want to call in the initialization script will call the compression loop so logs will be compressed later on. For that, we're going to call workers.log rotation loop. That log rotation loop is going to work much in the way the workers.loop does, whereas it is just going to call rotate logs once every 24 hours. So we can go ahead and write that. It is a very small function. It is a timer to execute the log rotation process once per day. So we're going to say workers log rotation loop is a function, and I'm going to copy workers.loop. So we're going to do the same thing. We're going to set an interval, but instead of calling workers.gather all checks, we're going to call workers.rotate logs. And instead of calling it once a minute, we're going to call it once a day. So 1,000 milliseconds in a second, 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day. So now once per day, this will get called. So now we need to go about writing what it's calling, write the rotate logs function. So just above it, I'm going to write that function, which will be to rotate, aka compress, the log files. Workers.rotate logs is a function, doesn't take any parameters. What it's going to do is start by listing all the non-compressed log files that are sitting in the .logs folder. The .logs folder, as time goes on, is going to be full of compressed files that are already zipped up and uncompressed files that need to be compressed. So the first thing we need to do is list everything that needs to be compressed. So we're going to start calling a bunch of functions that don't exist yet. Then we're going to go in and actually write those functions. So that first function that doesn't exist is called logs dot list. We're going to pass it false because when we write it, we're going to allow the user, whoever's calling this function, to pass it a Boolean indicating whether or not it should include compressed files in its list that it gives out of all the logs in the folder. If you say logs.list true, then it will give you all of the logs, including the compressed ones, but we want to just have the non-compressed ones, so we're going to pass it false. So logs.list false, and it's going to pass us back an error and a whole bunch of logs in an array. So if there is not an error, and there are logs, and the logs have a length, then we'll continue on. Otherwise, we're going to simply log out error, could not find any logs to rotate. But if we were able to find a whole bunch of logs that need to be compressed, then we are going to call logs for each and start looping through them. So as we go through each one, we want to compress the data to a different file, and then we'll go about actually emptying out or truncating that log file that we are working with. So we want to say that the log ID that we are getting that's coming from this log name is going to be the same as the log name, except we need to replace .log with an empty string. Just like we had to strip .json off of the files that we were storing in the data folder, we need to strip .log off of the logs that we're storing in the .logs folder. So the ID is the same file name without .log. So the new file ID, the new compressed file that we're going to create, is going to be the same log ID, but we're going to add on a dash and then the current timestamp. So it'll be very easy to identify which logs are compressed and which aren't. The uncompressed logs that are just getting filled up with today's data are going to be just an ID, and the compressed logs that reference data from yesterday or some date in the past are going to be an ID and then a dash and then a date timestamp representing the moment in time that that log was compressed. So now we have the new file ID. We can call another function that doesn't exist yet, which is logs compress. We want to tell it to compress log ID. So we're identifying the log, and we want to move everything to new file ID, and we want to get back an error. If there is no error, we'll continue. But if there is an error, then we want to log out error compressing one of the log files, and we might as well log out whatever that error was. But if there is no error, then we want to go about truncating the log. And by truncating the log, I mean emptying everything out of the original log file that we are rotating through that came to us as log name. So in other words, emptying out this log file after we've gone about taking the contents out of it and moving the contents to a new compressed file. So we're going to truncate the log, which means we'll call logs.truncate, which also doesn't exist yet. Pass it a log ID and expect back an error. If there is no error, we're going to log out success truncating log file. And if there is an error, we're going to log out error truncating log file. So that's everything that we need to do in the workers file, but as you can see, we've got our work cut out for us. We need these new functions written in this new logs library. So let's go about doing that. We might as well start with logs.list. As I mentioned, this function is going to list all the logs and optionally include the compressed logs. And it's going to optionally include them via that Boolean. So lib.list is a function that takes in a Boolean of whether or not they should include compressed logs in the list and a callback. We're going to use the file system function readder, or however you say it. We're going to call the base directory, and they're going to pass us back an error and data. We're going to say if there is no error and there is data, and that data array has a length, then we'll continue. Otherwise, we're just going to call back the error and the data to whoever called us. If everything was fine, we want to create an empty array that will eventually hold all the trimmed file names, the file names without the .log on them. So we're going to say data for each. It's going to be a function that gives us file name. And now the strings that we add to the array will depend on whether or not this string represents a compressed log and whether or not we are supposed to include the compressed logs. So the first bit of data will be just for the .log files. So add the .log files, which we always want to do. So we want to say that if the file name index of .log is greater than -1. So in other words, if the file name includes the string .log, then we can go ahead and push that name onto the array after we strip off .log. So trimmed file names push, file name replace .log with an empty string. Now we want to optionally add on the compressed files, which for our case are going to be called .gz.b64. That is because we are doing zlib compression, which normally makes things end in .gz, but then we are base64 encoding them so that we can read them easily later. So we're adding on the .b64 extension as well. So we're saying we want to add on the .gz files to this array. So we're going to say if file name index of .gz.b64 is greater than -1, and the include compressed logs Boolean is true, then and only then do we want to add them to the array as well after we trim off their extension. So trimmed file names push file name replace .gz.b64 with an empty string. Lastly, after we've gone through this for each loop synchronously, we want to call back to the requester, no error, and then the array of trimmed file names. So that list function should be working. We can move on to the next thing that we needed, which is lib.compress. And in order for us to easily test out whether compress is working, we should also write lib.decompress afterwards. So lib.compress is going to compress the contents of one .log file into a .gz.b64 file within the same directory. So it is going to be a function which, as we know, takes a log ID, a new file ID, and a callback. We need to first define the source file. So that's going to be log ID .log, and the destination file that this compressed data needs to go to. So destination file equals new file ID .gz.b64. Now we want to read the source file. For that, we're going to use fs.read file, pass it in the base directory plus the source file name. We want to read it in with UTF-8 encoding, and they're going to pass us back an error and the string contents of that file, which we're going to call input string. If there is no error and there is an input string, we'll continue to try to compress that input string. Otherwise, we're just going to call back the error that we got. Now we want to compress the data using gzip. Gzip comes with the zlib library, and now we are going to compress that string into data through that library. So we're going to say zlib.gzip and then pass it the input string. And we're going to expect back an error and a buffer. The buffer is going to contain the compressed data. If there's no error and there was a buffer, we'll continue. Otherwise, we'll call back that error that we got to the requester. If everything was fine, then we want to send the data, the new compressed data, to the destination file. So we want to fs.open the destination file. That's going to be lib base directory plus destination file. We're going to open it with the wx flag for writing and expect back an error and a file descriptor. If there is no error and there is a file descriptor, we'll continue to write to the destination file. Otherwise, we're going to call back the error that we got. For writing to the destination file, we're going to use fs.writefile. We're going to pass it the file descriptor, pass it the buffer, but then we are going to call built-in function on this buffer called toString, and we want to pass it the parameter base64 so it knows to make a base64 encoded string. So in other words, this buffer is going to become a base64 encoded string so that it can be written to a file. And that write file function is going to pass us back an error. If there's not an error, we should close the destination file. Otherwise, we should call back the error. If we're closing the destination file, we're calling fs.close with the file descriptor. And again, if there's no error, we want to call back false. And if there is an error, we want to call it back. All right, so that is how you compress a file using gzip, which is part of zlib, and how you base64 encode the string so that you can write it to a text file. So now that you have that kind of data compressed into a file, at some point you'll likely need to decompress it. So let's just write that function. Even though we don't have plans to use it right now, it will be useful later. So we want to decompress the contents of a .gz lib.b64 file into a string variable. So lib.decompress is going to be a function that takes in a file ID and a callback. We're going to construct the file name as file ID plus .gz.b64, and now we're going to call fs read file, pass it the base directory plus the file name, tell it to UTF-8 what we're reading, and expect back error and the string. If there is no error and a string, we're going to continue. Otherwise, we'll call back whatever that error was. If there was a string, we need to decompress the data. So we're going to create a buffer out of this base64 encoded string. So we're really doing the reverse steps that we did before. Before we started with a string, created a gzip buffer out of it, and then sent that buffer to base64 encoded string. Now we're starting with the base64 encoded string, we're decompressing it into a buffer, and then we're going from a buffer, unzipping that buffer into a plain string. So first we need to decompress the data, var input buffer equals a new buffer from this string, which we know is base64. So we're saying create a new buffer out of these beginnings. Now we want to call zlib unzip, which is the opposite of the zip that we used, the gzip. So zlib.unzip, pass it the input buffer, and we're going to expect out an error and an output buffer. If there is no error and there is an output buffer, we'll continue, otherwise we'll call back whatever that error was. But if we got the output buffer, then we just want to call back in general, which means we need to create a string out of this buffer. So we're going to call string equals output buffer to string without any parameters. Now we have a string to call back, so we can call back no error plus the string. So that's our decompression function, and we'll go about testing that later on. Lastly, one of the functions that we called in workers was lib.truncate or logs.truncate. So we need to have a function for truncating a log file. So lib.truncate equals function. It takes in a log ID and a callback. And it's just going to call file system truncate, pass in the base directory plus the log ID plus .log. Tell it to truncate it all the way and expect back an error. If there is no error, we'll call back false. And if there is an error, we'll call it back. So that is our whole logs library. Now we can start our workers back up and see if this log rotation and compression is working properly. And now we can actually just start it up. It's going to call rotate logs immediately, which should do everything we need. We don't need to worry about the log rotation loop firing again because it's not going to happen again for 24 hours. Let's start it up. Looks like we have an error, and it looks like this happened because I included these parameters incorrectly. I wasn't supposed to separate this with the plus, I was supposed to separate that with a comma. So let's kill that and try it again. Okay, looks like logging to the file succeeded as it was before, and we have 2 success truncating the log files messages logged out, so I'm going to kill that. And let's look at what's actually living in this part of the file system now. We have our original logs, which now just have 1 line each, and you can see that is because we just logged to the files, and we just logged to those files after the truncation happened. But the truncation happened, which means we have all this base64 encoded data inside of these .gz, .b64 files. So compression is happening, and after the compression happens and wipes out those files, those logs are still getting filled up as normal. So logging and what we call log rotation is working fine. That is how you log to the file system. In a later lecture, in a future section, we will actually use that decompression function, but for now, we don't really need it, and we'll look into that in more detail when we actually need to decompress some logs. But for now, everything is working fine, and so we can move on to the next lecture, which is about more logging, but is about logging to the console as opposed to log files.